Sequences and series. Unit 1. Sequence. A function f of n is called, which is a real number, is called a, which tends to a real number, is called a real sequence. A sequence is usually denoted by xn. The terms of the sequence are denoted by x, x2, x3. These are the examples. So for the first one, you can see this is 1, 2, 3, so it would be n. So n would be 1, n would be 2, n would be 3, and the denominator is n plus 1. So 1 plus 1 is 2, 2 plus 1 is 3, etc. And this one is just n, so 1, 2, 3, 4. And this is 2 to the n minus 1. So 2 to the 1, which is 2 minus 1, which is 1. 2 to the 2, which is 2 squared, which is 4, minus 1 is 3. 2 to the cube is 2 to the 4 to the 8, minus 1 which is 7, and etc. Then this is called an alternating sequence, where you have minus 1 to the power of n. So minus 1 to the power of 1, which is minus 1, minus 1 to the power of 0. For the first one we have used 0. The second one we have used to the power of 1, which is minus 1, and then minus 1 squared. So minus 1 times minus 1, which is 1. And then this function, for n is 1, it will be 1 by 1. For n is 2, 1 by 2, etc. The set of all distinct terms of the sequence is known as the range of the sequence. So this is for a bounded sequence. A sequence xn is said to be bounded if there exists such that the modulus of x of n is less than m for all of n. So here it's given x1 is 1 by n. So 1 by 1, then 1 by 2, etc. to the 1 by n. And the modulus, you can see here the x of n. In this case, it would be the last term, which is 1 by n. So x by n, which is 1 by n, and the modulus of that, which is less than or equal to 1, where m is 1 in this case for all of n. So it's a bounded sequence, and xn is n squared. So if you have n squared in this sequence, it's not going to be bounded. Monotonic sequences. You have a monotonically increasing sequence. A sequence xn is said to be monotonically increasing if x1 is less than x2 is less than x3. And xn is less than xn plus 1. Then the next one is a monotonically decreasing sequence. A sequence xn is said to be monotonically decreasing if x1 is greater than or equal to x2, which is greater than or equal to x3. For example, xn is greater than xn plus 1 for all of n. And for the previous question, for a bounded sequence, for this question here, it is said n squared. In this question, 1 divided by 1, so n is 1, 1 divided by 2, so n is 2. So if you plug in 1 into here, you will get 1 squared. Is 1 squared, which is 1, less than or equal to 1 if m is 1? Right? So that is true. So for the second one, 2 squared, which is 4. 4 is not less than or equal to 1, so it is not bounded. Then you have a strictly increasing sequence. A sequence xn is said to be strictly increasing if xn is less than xn plus 1 for all of n. A sequence which is either monotonically increasing or monotonically decreasing is called a monotonic sequence, because monotonic sequence consists of monotonically increasing and monotonically decreasing sequence, so that's why it is like that. Now for this question, we can try some numbers. So 1, so 1, 2, say 1, 2, 3. So the first term would be 1. 1 is less than 2, 2 is less than 3. Or you can see the Fibonacci sequence, 1, then 1, then 2, then 3, then 5, right? So in this case, x1 is equal to x2 because 1 is equal to 1. So you have less than or equal to, so for this one it is equal to, and for this one it is less than. And this is generally an increasing function. It is increasing as you go on, and this is also increasing. Right? And the general term xn is less than or equal to xn plus 1. So this is just the same as this. It's just a general form, because if you take n is 1, here it will be 1 plus 1, which is 2. So it matches up. Then for a monotonically decreasing sequence, for here you can have 5, 4, 3, 2, 1. So 5, 4, 3, 2, 1. For this, x1 is 5, x2 is 4, x3 is 3. So for this one, 5 is greater than or equal to 4, 4 is greater than or equal to 3. So it works here. And this is the general thing. So n is 1. If n is 1, then 1 plus 1 is 2. Now for a strictly increasing sequence. Strictly increasing if xn is less than xn plus 1. So for this one, you're going to have x1, which is less than x2, which is less than x3. Now this strictly increasing sequence, if you have plugged in n as 1, you'll get this here. So you can have 5, 4, 3. I mean, sorry, this is wrong. Three, 4, and 5. Why is it 3, 4, 5 and not 5, 4, 3? Because the number on the left, which is always going to be smaller than the number on the right. So this one is strictly, right? It's strictly increasing. So this is different from monotonically decreasing. I mean monotonically increasing. Why is that? Because this has a less than or equal to sign. So for this it is strictly increasing, and for this it is It can be equal to also, as you see in the Fibonacci sequence. And this is a strictly decreasing sequence, right? So here you would have, say, x1 and then x2 and x3. So this has to be greater, so you can have 5, 4 and 3, because the number on the left is always going to be greater than the number on the right, and carrying on in the sequence. Okay, now limit of a sequence. Let xn be the sequence is said to be a limit x, if given, is greater than 0. So n naught is real numbers. Xn is the modulus of xn minus x is less than that for all numbers n. You can write the limit as n approaches infinity. Xn is equal to x, or xn approaches x as n tends to infinity. Now this is the same as this thing here. Now if limit xn is a finite and unique, then xn is said to be convergent. So if you have a limit here when n tends to infinity, so in this case you would make n equals to infinity and you get some number here. Okay, so then this is going to be a finite because it ends, right? And it's unique because you get one number, and it's convergent. Convergent means it converges at a single number, so that number would be here in this case L. So example, so xn is equal to n squared minus 2n divided by 3 n squared plus n. So you take out the common of n squared, right, and you get this. Now you are doing limit as n approaches infinity. You have taken this from here, right, and you simplify this down, you cancel this down, and when n tends to infinity, you do 1 minus 2 divided by infinity, right? So this thing can be approximated as 0. So therefore 1 minus 0, so 1 minus 0 divided by 3 plus 0, which is 1 by 3. Okay, then the next question, xn is 3n divided by n plus 4 root n. So limit as n tends to infinity, you do the same thing, take out the common of n, and same thing goes here. When n tends to infinity, it would be 1 divided by infinity, which would be 0. So 3 divided by 1, which is 3. So if this sequence is convergent, then the limit is unique. Limit as n tends to infinity, xn is not unique, then xn is said to be oscillatory. So what does oscillatory mean? So now you have xn is minus 1 to the power of n. So if n is 1, minus 1 to the 1, which is minus 1, then minus 1 to the 2, which is minus 1, times minus 1, which is 1. So here they have done 1 and then minus 1. So 1, which is even, and minus 1 is odd. So in this sequence, you're going to have an oscillatory, which means it's going to oscillate between minus 1 and 1. So xn is oscillatory. If limit n tends to infinity, xn is plus or minus infinity, then the limit n tends to infinity, xn is infinite, then xn is said to be divergent. So instead of getting a number, you get plus or minus infinity, then it's going to be divergent because it does not converge to a single number, but it just becomes an infinite number, right? So it's divergent. Examine the convergence of following sequences. Xn is 3n minus 1 divided by 1 plus 2n, and this question here. So what would you do is do the limit as n tends to infinity. You take out the common of n. You do 1 divided by infinity, which is 0. So you get 3 by 2 here, and these n's cancel out. Same thing, you apply this limit as n tends to infinity. Now here they have separated this into 1 comes here and 2 divided by n. Now this is the same as this. So you get 1 here and 2 divided by infinity, which is 0. So it just becomes 1. So 3 plus, that's meant to be a plus, minus 1 to the n. So as limit n tends to infinity, so this is an oscillatory from the previous example. So you're going to get 3 plus 1, which is 4, n is even, and 3 minus 1 is 2 if n is odd. So it doesn't have a unique limit, hence xn is oscillatory. Okay, and these are homework questions. I'll leave this slide on for 10 seconds. Okay, now important formula. Limit as n tends to infinity x to the n is equal to 0 and 0 if x is between 0, x is greater than or equal to 0, and is strictly less than 1. Infinity if x is greater than 1, 1 if x is equal to 1. Now these important formula you'll have to use in the future for attempting the questions. So I'm not going to go through these formula. So this is a series. Let x1, x2, x3, x4 be a sequence of a real number. Okay, so this is a sequence because it has a comma. Okay, now when you're adding it, it is called a series. So a series is denoted by the sum of x of n between infinity and n is 1. So n is 1 will be the first term, x is x1, and infinity will be the term where it keeps on going forever. Okay, so that is denoted by this, and summation is the summation sign. So it just simply means that you're adding all of the terms between these two limits. Sequence of partial sum be an infinite series. S1 is x1, S2 is x1 plus x2, S3 is x1 plus x2, etc. Okay, is known as a sequence of partial sum. So here it's a partial sum because every time you're adding the previous number and you're adding the new term. So you're adding the previous term, so S2 is going to be S1 plus x2, S3 is S2 plus x3, etc. So it's a sequence of partial sum. Convergence and divergence of series. Let x of n between infinity and 1 be an infinite series with partial sum Sn. If Sn tends to a finite number, say L, as n approaches infinity, then the series converges to L. If Sn tends to I to the infinity as n approaches infinity, then the series diverges. If Sn does not tend to be a unique limit as n approaches infinity, then the series is said to be oscillatory. Example, 1 plus 2 plus 3 to the n. So this is the summation between n of n between 1 and infinity. So n would just simply be 1 to 3, etc. Right? So S of n is just n times n plus 1 by 2. So you do the limit between n and infinity here on both sides. And you have n here, right? So if you substitute n as infinity here, so you're going to get infinity multiplied by this inside thing, and infinity multiplied by any number which is infinity. S of n diverges. The series is divergent. For a geometric series, 1 plus r squared plus r to the n is 1 minus r to the n divided by 1 minus r. So the first term, which is 1, the first term is going to be a is 1, and the common ratio, which is r. Okay, so the is denoted by a times 1 minus r to the n over 1 minus r. In this case, a is 1, so hence you get 1 minus r to the n and 1 minus r as shown in the question. The sum of n is 1 plus a half squared plus 1 plus half plus 1 by 2 squared plus 1 by 2 cubed. This is a geometric series with common ratio half. So here r is the ratio, right? Common ratio, which is half. So that means that you're multiplying each term by half. Okay, so it can be denoted by this thing, and you just substitute the half here. So you're going to get 2, right? 1 minus half is a half, and a half, 1 divided by half, which is going to be 2. So 2 multiplied by 1, which is 2, and this term would become half to the infinity, which is 0. So it would just be 2. So the given series converges to 2. X of n 1 plus 3 quarters plus 9 by 16 plus 27 by 64. So the common ratio is 3 by 4. This means that every time you multiply the previous term by 3 quarters to get the next term. So you substitute in the formula 1 minus r to the n divided by 1 minus r, okay, where r is 3 quarters. So you find a limit as n tends to infinity. So anything to infinity, which is 0, 1 minus 0, and this is a quarter. So 4 multiplies by 1, which is 4. So the given series converges to 4. This is a geometric series, a plus ar squared plus ar cubed. Summation of ar to the n between n is 1 and infinity. So it converges if modulus of r is less than 1, diverges if r is greater than or equal to 1, and it oscillates if r is less than or equal to minus 1. So if r is minus 1, then you would have an oscillatory series, okay, as shown in the previous one. And if r is less than 1, here r is less than 1, so you get it converges to something, okay. And for all of these questions, it's converging. But for this one, right, it's and moving on. So auxiliary series. Now auxiliary series is different from geometric series, right? Because it looks the same but it's different. You know why? because it's going to be, so you have 1 2 3, so that's going to be n, okay, n, and then you have to the p, which is a power, right? So the, and for this one it would be multiplied by the common ratio. So for this question you can have, okay, if p is 2, okay, if p is 2, right, if p is 2, you're going to have 1 divided by 1 squared plus 1 divided by 2 squared plus 1 divided by 3 squared. Now this is different from the geometric series because there is, the common ratio does not exist, okay, so you cannot multiply one, so this one would be 1, and then this one would be quarter, and this one would be a ninth. Okay, so there you cannot multiply this one by any, say, quarter. So if r was a quarter, you cannot multiply quarter by a quarter to get 1/9. So the geometric series does not work with this, so that's why it is an auxiliary series. So it converges if p is greater than 1 and diverges if p is less than or equal to 1. So this is the exact opposite of this. And these are some homework questions. I'll leave this on for 10 seconds. Okay, so if a series xn between infinity and 1 is convergent, then limit as n approaches infinity, x of n is 0. Here's the proof. The sequence of a partial sum, okay, since the limit between x of n is convergent, s of n tends to x. X is finite and unique. x1 plus x2, xn minus 1 plus xt. So Sn is Sn minus 1, Sn minus 1 is x of n. So if you remember from before, right, so this S4 minus S3, okay, so you're going to have here S4 is S3 plus X4. How do I know that? It's because of this here. So x1 plus x2 plus x3, which is S3. So this is here. So here, in this case, it will be Sn plus 1 minus Sn, which is equal to xn. Okay? So here n would be 3. So this is, I have taken S3, I've subtracted S3, okay, and I have equal this here. Sorry, this is x3. Okay, no, sorry, it's this is x4. plus 1. Okay, so from the previous question, you have, from the thing down, you have this here, right? So here if you substitute, S4 is S3 plus X4. S4 is S3 plus X4. Okay, so here S4, which is S3 here, plus X4, and here N is 4, and it works with this formula here. And this they have taken Sn, and you have subtracted Sn minus 1 from both sides. Okay, so if you take the limits S minus S1, right, you get X minus X0. So if Sn is equal to X, right, X minus X here. Okay, and you get 0. So if it's not equal to 0, then the series must be divergent. So whenever it is 0 or infinity, it's going to be divergent. Okay, so here's the example. So here you have n is 1, 2, 3. Okay, then you have n plus 1, so 1, and then 1 plus 1 is 2, and 3, 4, etc. So x of n is n divided by n plus 1, and limit of xn, we find the limits as n tends to infinity. We take out the common factor of n, and 1 divided by infinity, which is 0, so 1. So the series is divergent. Okay, okay, so when it's not equal to 0, then it is divergent. So here you have n squared minus 1, so 1, so you have 1, then 2, so 2 2s are 4 minus 1, which is 3, 3 3s are 9 minus 1, which is 8, etc. Then you have n squared plus 1, so 2 2s are 4 plus 1, which is 5, 3 3s are 9 plus 1, which is 10, etc. Here xn is equal to this here, and limit as n tends to infinity, you take out the common of n squared, it cancels down to 1, which is not equal to 0. So the series is divergent. And here it is 1 divided by n, so 1 by 1, and 1 by 2, 1 by 3, n, right? Here xn is 1 by n, and limit as n tends to infinity, which is going to be 0. So 1 divided by infinity, which is 0. And here we cannot conclude. Then here is 1 plus 1 by 4. So here you're going to have 1 by n squared. Okay, so xn is that, and then limit as n tends to infinity is 0. And here also we cannot conclude. Then here it is 1, 3, 7, and 15. So it is 2 to the n minus 1. 2 to the n plus 1. So 2 to the 1, which is 2, minus 1, which is 1, and 2 squared, which is 4, minus 1, which is 3. Here it will be 2 to the 1 plus 1, which is 3, and 2 squared, which is 4 plus 1 is 5, and etc. So this is the xn, and limit as n tends to infinity. You can take out the common of 2 to the n, and as n tends to infinity, this fraction is 0. So 1 divided by 1, which is not infinity, which is not 0. So the series diverges. This is a positive term series. An infinite series which contains only finitely many negative terms is called a positive term series. So what does this mean? It's infinite, so it goes on forever, but it contains only a finitely many negative terms. So only a limited amount of negative terms. So it is called a positive term series. Why is it positive? Because if it's going on forever and you have a limited number of negative ones, then you're going to have a certain number of positive ones. Okay, overall you'll have a positive. So that's why it's a positive term series. Adding or removing finite number of terms from the infinite series does not affect the convergence of series. To test the convergence or divergence of a series, you can use comparison test, dAlembert ratio test, Cauchy's root test, integral test, Raabes test, Leibniz test for alternating series. Comparison test. So if the sum of un and vn, sum of vn, be two positive term series such that un by vn, the limit says n tends to infinity, is k, where k is finite and non-zero, then un and vn behave alike. Both converge together or diverge together. So un, this ratio here, now it's a comparison because you're comparing this thing here, and it's like a ratio, so both of them behave alike. Okay, this test is applied when the n terms un of sum of un contains power of n only. In such cases, vn is chosen by vn is 1 divided by n to the p minus q. What is this p minus q? So p is the degree of the denominator and q is the degree of the numerator. So in other words, if you have x to the 5 and x to the 4, so the degree of the denominator, which is 4, the degree of n in the numerator, which is 5, so Vn is 1 divided by n to the power of p, which is 4 minus 5, which is minus 1, so it becomes n. Here's the example. So sum of un is this. So here you have n is 1, so n is 1, n is 2, 1 to 3, etc. n squared plus 1, 1 squared, which is 1, plus 1 is 2, then 2 2s are 4 plus 1, which is 5, 3 squared, which is 9 plus 1, which is 10. So un is that here, and vn is going to be the degree 1 divided by the n to the power of 2 minus 1, which is 1. So limit as n approaches infinity, un divided by vn. So both of them behave alike. Okay, so when you do this, you're going to divide this here by this here. So you're going to cross multiply, and the n's cancel out. Then you have, you multiply the n to the top numerator, take out the common factor of n squared, and 1 divided by infinity, which is 0, so it becomes 1. Okay, so 1 divided by n is divergent, so Vn is divergent. So Un is also divergent. Why is that? Because Un, sum of Un and sum of Vn behave alike. So 1 divided by 1 times 3 plus 1 divided by 3 times 5 plus 1 divided by 5 times 7. Okay, so 1 divided by 2n minus 1, so the first term, 2 minus 1, which is 1, 2 2s are 4 minus 1, which is 3, 1 3 5, this is a odd, and this is also odd. So 2 1s are 2 plus 1, which is 3, 2 2s are 4 plus 1, which is 5, so this is also odd. Here degree of n in the denominator is 2. Why is it 2? Because 2 times 2 is 4, n times n is n squared, so the degree which is 2 because of the n squared. And the numerator, it is 0 because there is no n, so it would be 1 divided by n to the denominator, power of the denominator, which is 2, minus 0, so 1 divided by n squared. So limit as n approaches infinity, un divided by vn. You want un, which is here, and vn, which is here. N squared goes to the top. You can remove common of n squared, cancel down, take out 1 divided by infinity, so 0 0 1 over 4. So as sum of un and sum of vn behave same, right, sum of 1 by n squared converges. So this is vn, vn converges, sum of un also converges because they behave the same. Next example, 1 divided by 1 times 2 times 3. Okay, first we write the series in a simplified form. The numerator is going to be 2 times n minus 1, so 2 times 1, which is 2 minus 1, which is 1, then 2 times 2 is 4 minus 1, which is 3, etc. Then the denominator you're going to have 1, so 1, and then 1 plus 1, which is 2, then 1 plus 2, which is 3. Okay, so 2 3s are, so here you have 1 2 and 3, and then the next one you're going to have 2 2, and then 2 plus 1, which is 3, and 2 plus 2, which is 4, etc., and you carry on. So you have un, which is going to be this here. Okay, the degree of the numerator in denominator is, so the denominator is going to be 3. Why is that? Because n, so cubed, right? And numerator is 1 here, and vn is going to be 1 divided by n squared, because 3 minus 1, which is 2, right? So you're going to divide un by vn as limit as n approaches infinity. So you can take out n cubed here, cancel it down, 1 divided by infinity, if all of these is 0, so you're going to get 2 divided by 1, which is 2. So as sum of un and sum of vn behave alike, this converges, so this also converges. Okay, in the previous problem we can simplify un. Okay, that is the same as the previous question. Okay, now question 4. Sum between 1 and infinity, n plus 1 minus the root of n. So the un is going to be this term here. Okay, and this can be rewritten as this. Okay, no, it can't be rewritten as this. We are multiplying by this root n plus 1 plus root n. Why? Because root n plus 1 minus root n. So here and here, if you notice here, you're going to get the difference of two squares, which is a plus b, which is a minus b, and a plus b. Okay, a plus b will be here and a minus b will be here. So the difference of two squares leaves you with a squared minus b squared. Okay, so that's why you do that. Okay, and you get 1 here. Okay, and that's the denominator here. Okay, so what is of the numerator? So Vn is going to be 1 divided by n to the p minus q. Now the denominator power is going to be root of n. Okay, and for the numerator 0, so half minus 0, which is just half. So limit as n approaches infinity, un divided by vn. So you take un from here and take vn from here. You multiply root n to the top, take out the, and you can make this simpler over here by doing this. So what have they done here is root n they have put in the denominator here, so it would be 1 over root n by root n plus 1 by root n. Okay, so this cancels down to 1 and this square root sign becomes of the whole thing, so n plus 1 by n. Okay, so 1 divided by infinity, which is 0, 1 divided by 1 plus 1, so that's meant to be a half. It's meant to be a half. So as un, sum of un and sum of vn behave alike, sum of vn 1 by n to the half diverges. So this one will also diverge. Okay, these are some homework questions. I'll leave it on for 10 seconds. Actually no, these are not homework questions. I think they've done it here. Okay, just question 7, right? Question 7. So un is going to be 1 by 3 to the n, 5 to the n, which is the same here. Taking out the 5 to the n, you get this, because this cancels out, right, and this multiplies here. So vn is going to be 1 divided by 5 of the denominator, which is n, minus the numerator, which is 0. So un by vn, limit as n approaches infinity. Put this to the top. No, this cancels with this. Yeah, so this goes on the top. which cancels down here. So as n approaches infinity, get 1 by 1, which is 1. As un, sum of un and sum of vn behave alike, meaning geometric series is convergent. So un also converges. So these are the homework questions. Okay. So I'm going to leave this on for 10 seconds. Okay. So she has done question 10 here. So un is 1 by n cubed. So it's the same thing here. Now you have just taken out the n cubed from here. The n cube was already here, so you have taken the n to the n, which cancels out. So n to the denominator minus the numerator. So 3 minus 0, which is 3. So un by vn.
Now see his face. It's very serious because I will have to do the recording all over again. If I lost it, I don't want to do that.
You will not lose it. I spend so much of time doing that, and I don't want to lose it.
You don't check.
So these are some homework questions. I'm just going to leave this on for 10 seconds. Okay, so this is the dAlembert ratio test. If sum of un is a positive term series such that limit as n tends to infinity, un plus 1 by un is L. The sum of un converges L is less than 1, diverges L is greater than 1. The test fails if L is 1. So here you have 1 divided by 1 factorial. So the common thing is going to be n to the n. Why is that? Because if n is 1, 2, 3 is going 1 and then 2 and then 3. So 1, 2, 3 and to the power of n, which is 1, 2 and 3. So n factorial is a factorial. So 1 factorial, 2 factorial, 3 factorial. What is a factorial? A factorial simply means that suppose it's 3 factorial, it is going to be 3 times 2 times 1. Okay, 2 factorial, which is 2 times 1, and 4 factorial, which is 4 times 3 times 2 times 1. Okay, so this is the factorial formula. Okay, so n will just be 1 and then as it goes on 1, 2 and 3 etc. So the un is going to be this here. Un plus 1 is going to be, you just simply add n plus 1 into this formula. So n plus 1 to the n plus 1, n plus 1 factorial, divide by Vn, right? So you want you have 1, so you, okay, so this was the formula given here. Limit as n approaches infinity, un plus 1 divided by un. So you got to do this, put this thing here and put this thing here. So the n factorials cancels out, and this, the n cancels out with the n minus n which is 0, and then 1. So n plus 1 divided by n to the n plus 1 divided by sorry, this is not to the n, this is n plus 1 to the 1. So 1 minus 1 which is 0, so n plus 1 to the n, and this n factorials cancels out. So you're going to get this, and n to the n comes here in the denominator. So you can take out the common of n, and like that. So it's going to be e, which is 2. The value of e is 2.718, etc. So which is greater than 1. So by dAlembert's ratio test, sum of un diverges. So this is the un here. Un plus 1 is just going to be 2 to the n plus 1 minus 1 divided by 3 to the n, etc. Okay, and here's the minus 1 here. So you want un plus 1 divided by un. So you want un plus 1 here divided by this here. So this goes to the top, the n's cancel, so it becomes the minus 1, so a third. Likewise this is here. Okay, you remove the 2 to the n as a common from both of them, and this becomes 1 divided by infinity, and this is also 1 by infinity, which is 0 and 0. So 2 divided by 1 is 2. Okay, these two terms cancel out, so you have 2. So it becomes 2/3, which is less than 1. So it converges the un. So n factorial 3 to the n divided by n to the n. So here you want to do u n plus 1. So substitute n plus 1 here, n plus 1 here, and you want to do un plus 1 divided by un. So this divided by this here. Okay, so after doing all that, you get n divided by n plus 1. Take out the common of n, and then it becomes 1 divided by e. Is 3 divided by e, which is greater than 1, so it diverges. So these are the homework questions. This is just one homework question. Then this is question 8. A half plus a half times 3/5, etc. Okay, so if you notice here, you're adding the multiplication of the previous term times the next term. So the previous term comes here. So this is the previous term, this is the previous term, etc. These are all the previous terms here by the new term which is here. Okay, so un is here and vn plus 1 is going to be this whole thing vn plus un plus 1, which is going to be un plus 1 is going to be 1 times 3 times 5 over 2 times 5 times 8. Okay, you want this thing here 2n minus 1, 2n minus 1, and you want 3n minus 1. Okay, and you want to multiply that by this thing here 2n plus 1, 2n plus 1. I don't have space here, so I'm going to write it down 2n plus 1 and 3n plus 2. So this is going to be multiplied over here by this. Okay, so this is included in this previous thing here. Okay, so this, as you get this by this, it cancels down. Okay, this, you remove the n as a common, 1 by infinity which is 0, so 2 by 3 you get, which is less than 1. So series converges. This is the next one. So you're going to have a similar thing. So n and 2n plus 1. So you can see here 2 times 1 which is 1 plus 1 is 3, etc. Then this is the next one. So un is n times x to the n minus 1. Un plus 1 is n plus 1, x to the n plus 1 minus 1. So you plug n plus 1 into n here, so you get this. So you do un limit as n tends to infinity, un plus 1 divided by un. So this is for dAlembert's ratio test. Okay, so it's a ratio because it has this ratio here, un plus 1 divided by un, etc. So x to the minus 1 divided by x to the minus 1, which is x, so x comes out, n plus 1 divided by n, so that cancels down to 1 divided by n to the infinity, which becomes x here. Okay, so en converges if x is less than 1 and diverges if x is greater than 1. So these are some homework questions. I'm going to leave them on for 10 seconds. Okay, now this is Raabes test. If u sum of un be a series of positive terms such that limit as n tends to infinity, n times un, so So limit of n as n tends to infinity, n times un divided by un plus 1 minus 1 is L. Then sum of un converges if e is greater than 1, diverges if e is less than 1, test fails if e is equal to 1. So this is an example here. So you do un plus 1. So same as the dAlembert's ratio test, you want to find un and un plus 1. Okay, so here it is, un plus 1 divided by un. So you do this and you get 1. So dAlembert's ratio test fails. So because his dAlembert's fails, so now let's try Raabes test. Okay, so that is here. So you want to multiply n divided by un plus 1 minus 1. So this goes in the numerator and this is in the denominator. So this cancels out and have this. So you want to divide by root n. So you can get this here. Okay, and 2 divided by infinity, which is 0. So you're going to have root of 1 minus root of 1. So 1 minus 1, which is 0, which is less than 1. So sum of un diverges by Raabes test. Half x plus x squared plus 9 by 8x cubed plus x to the 4. Here un is going to be n squared x to the n divided by 2 to the n e to the n plus 1. So you check by dAlembert, un plus 1 divided by un. So this divided by this, and this is just going to be substituting n plus 1 here, and here it is going to be n squared. So 1 ones are 1, 2 2s are 4. So this is going to be 4 here, 4, and this is going to be 2 to the n. So 2 to the 1, which is 2, 2 to the 2 is 4. So this cancels to 4 by 4, which is 1. Okay, similarly 1 2 3 4, this is 3 squared, which is 9, 2 cubed, which is 8, x to the 3, which is x cubed. Okay, so dividing this by this, you can also cross multiply. Okay, limit as n tends to infinity. Include this in the denominator, move the x by 2 out. This becomes x by 2. X by 2 is greater than 1, then un is divergent, x by 2 is less than 1, sum of un is convergent, x by 2 is 1, x is 2, then test fails. Then apply Raabes test for x equals 2. So if dAlembert's test fails, now this is dAlembert's ratio test. Okay, if dAlembert's test fails, okay, x is 2, then apply Raabes test for x equals 2. So you have all three scenarios. So un plus 1, etc. So you use this formula here. You want to simplify it down. And you're going to get minus 2, which is less than 1. So un is divergent for x is greater than 2 is convergent for x is less than 2. So here also it is the same, x is less than 2 it is convergent, x is greater than 2 is divergent. Okay, but here it's more specific, greater than or equal to. So you have another one, n factorial, so 1, 2, 3 factorial, and you have x plus 1 etc. to the n minus 1. X plus n minus 1. So if you substitute 1 minus 1 is 0 here, 2 minus 1 is 1, so 1 and 2 etc. So apply dAlembert ratio test. First, un plus 1 divided by un, so un plus 1 which is this, divided by un, so cross multiply, cancel it down, remove the n, becomes 0 here to 1, and it fails. So when it fails, you can apply Raabes test. You apply this formula here, n times un by un plus 1 minus 1. Substitute the values, get x minus 1. So, and you do sum of un converges if x minus 1 is greater than 1, greater than 2, and diverges if x minus 1 is less than 1.